Hello students, now we are going to look at the operations management applications of LPP, linear programming application. The first one is a make or buy decision. The case goes like this: the Genders company markets various business and engineering products. Currently, Genders is preparing to introduce two new calculators, one for the business market called the financial manager and one for the engineering market called the technician. Each calculator has three components: a base, an electronic cartridge, and a faceplate or top. The same base is used for both the calculators, but the cartridge and tops are different. All components can be manufactured by the company or purchased from the outside suppliers. The manufacturing cost and purchase prices for the components are given as below. So these are the five components: base, financial cartridge, technical cartridge, financial top, and technician top, right? So two tops, two cartridges, and a common base. So if you are manufacturing on a regular time, then these are the costs per unit: $0.5, $3.75, etc. And if you are purchasing from an outside vendor, then they are $0.6, $4, etc. Now, company forecasters indicate that 3,000 of financial manager calculators and 2,000 technician calculators will be needed. However, the manufacturing capacity is limited. The company has 200 hours on regular manufacturing time and 50 hours on overtime that can be scheduled for the manufacturing of calculators. Overtime involves a premium at an additional cost of $9 per hour, right? So basically there is another table which is giving you now the time required per unit, the manufacturing times in minutes per unit of these calculators. So if it is a base, then 1 minute per base, financial cartridge 3 minutes per base, technician cartridge 2.5 minutes per base, then financial top 1 minute per base, and technician top 1.5 minutes per top, right? So basically these are the manufacturing times requirements. The problem for Genders is to determine how many units of each component be manufactured and how many units of each component to purchase. We define the decision variables as follows. So overall total cost we need to minimize, right, by deciding a right proportion of manufacturing of these five items and purchasing of these five items. So the variables will be declared as like this: BM stands for number of bases manufactured, BP stands for number of bases purchased, FCM stands for number of financial cartridges manufactured, financial cartridges purchased, technician cartridges manufactured, technician cartridges purchased, financial top manufactured, financial top purchased, then technician top manufactured and technician top purchased. So these are our variables, and let OT be the number of hours overtime to be scheduled. Right now, the total cost we will write, and that total cost will be minimized. So the objective function is to minimize the total cost, right? So basically all these items into their corresponding prices, 0.5, 3.75 for manufacturing and purchasing 0.6. So if you look at the first two, one is 0.5 is for purchasing the business, the base manufactured, and 0.6 is the base purchased. So that is how we will combine this all this, and we will add, multiply and add, multiply and add. and then finally we'll also add $9 into the overtime time, right? So this is the objective function which we are going to minimize. Now the constraints are basically here. The first five constraints are here basically because we are going to complete our requirement 3000 plus 2000. So the total bases are required will be 5000. So that is what is given here. BM plus BP 5000, then FCM plus FCP 3000, and FTM and FTP 3000. Then TC, that is technician top, a technician cartridge plus a technician cartridge purchase and manufacture 2000, technician top manufacture and technician top purchase is 2000, and the overtime they have given that it should not be more than 50 hours. So these are the requirement equations, but then we have to now put into the manufacturing time. So this one per unit. So this is that equation where all this will add up to the manufacturing time required, and on the right side it should not exceed more than 12,000 minutes. Why 12,000? Because 200 hours is our regular time into 60 minutes. So 1200, sorry, 12,000 minutes plus 60 times OT, because this OT is also hours. So we have $9 or nine times OT, and it is, the price is given as $9 per hour, $9 per hour, right? So that is why we have to say 9 times OT, and OT we will multiply by 60 so that it becomes minutes. So this is my final entire model to decide the manufacturing and procurement mix of all these 5 items. So when you make this, really when you run this on Excel solver, this is the answers you will get. You can check it out. So these are the values, and this is the total cost which you are going to incur. Okay. So this is the manufacturing and purchase problem for LPP. Thank you.